Welcome back to Chapter 12. We are in Section 6, and we're going to look at the surface area and volume of just a sphere today. So remember, the surface area is in units squared, and our volume now will be in units cubed. So just to recall your memory, a few things that I think about in real life when I think about a sphere. One being just the earth that we live on, it is almost like a 3D circle. So that's the first thing that comes to my mind. And then there are so many of those spheres in sports. One being my favorite, a volleyball, and then a soccer ball. Or, of course, you can always go to baseballs or water polo or lacrosse. So all of those types of things that we use in sports can be referred to in geometry as a sphere. So what is a sphere exactly? It's a set of all points in a shape equidistant from a given point. So that definition is very similar to our circle. Now we're just in a 3D object. And that given point will now be our center. So the given point from which all points on the sphere are equidistant. So if I had a center, in the middle of this soccer ball, all points from that are equidistant to the sides of my sphere. So you can look at that as a 3D shape. Radius, if you refer back to what we know about a circle, the radius is going to be the same thing, although the radius is now inside the circle. So it's a segment from the center to a point on a sphere. And at the left, you can notice that if this is my center, my radius is going to be there to the outer edge of my sphere. A chord, again, the same type of concept that we know in a circle. So the chord of a sphere is going to be a segment that goes from one edge to the other edge of the sphere. And again, that chord will be on the inside of our sphere, not necessarily on the outer edge anymore. Diameter, again, same concept. It's a chord that contains the center of the sphere. So our diameter is in red up here on the top. So it goes through the center and it goes from one side to the other. A new concept that we haven't really seen before, it's called the great circle. So it's an intersection of a sphere and a plane that contains the center of the sphere. So a little bit like a cross section, along with having to go through that center of our sphere. So to the left over here, I've kind of put a couple good examples that I found to kind of demonstrate what is that great circle. So again, they have kind of outlined this in red, but the center will be on that plane that it is of the intersection. And then last is the hemisphere, and you can kind of identify that with one of the congruent halves of a sphere. So it doesn't necessarily have to go, completely horizontal or completely vertical, but it just has to be congruent halves. And notice with this, it does contain that greater circle. And I think of the hemisphere as, when I refer back to the circle, as kind of the semicircle. It's half of my whole sphere. Continuing on with this, we're going to go to Theorem 12:11. Knowing the surface area of our sphere equation will be 4 pi r squared. So I kind of say that as the surface area is 4 times the area of the circle created, or you can call that the greater circle. So this is, again, will be in units squared. Alrighty, let's put that formula into use. Again, let's rewrite it. So our surface area equals 4 pi r squared. I think the more you write that equation, the more familiar you will be with it. And really the only thing we need is that radius to plug in and solve. So we're going to substitute 7 for r. So we'll get 196 pi, which is approximately 615.75. And we are in surface area. And remember, area is in squared units. So we're going to keep that in squared units, centimeters squared. All right, example 2. Now they're going to give us our surface area. And we need to find the diameter of this. So we're going to substitute 110.25 pi in for S, or our surface area. So 110.25 pi equals 4 pi r squared. And we're going to divide both sides by 4 pi to get that to cancel. So 110.25 pi divided by 4 pi will give us a 27.5625, and square root both of those sides to get our r to become 5.25. And we know that our radius is half of our diameter, so we just need to multiply it by 2 to get our diameter. So our diameter then would become 10.5 feet. And again, I think I try to remind you that since it's just a distance, we don't have to put squared or cubed on it. Alrighty. And the volume of a sphere, so just to recall what we have already done in this section, the surface area is just looking at what's on the what is the solid made up of on the outside. So kind of like if you look at an M&M, the outer edge, the colored chocolate candy piece on the outside is going to be our surface area, and then the chocolate filling is going to be our volume. So that's what we are going to find here. So our volume is 4/3 pi r cubed, and that is something definitely new that we haven't seen yet, that r is going to be cubed. If you need to find a hemisphere volume, you know that the hemisphere is half the sphere. So we're just going to say 1/2 times our volume equation of our sphere. And again, this is in units cubed units. All right, we need to find the volume of our sphere. And again, the only thing we really need is that radius. So we are given that. We're going to substitute 3 millimeters in for r. So it'd say 4/3 pi 3 squared, which would give us about 113.1 cubic millimeters. Pretty easy stuff so far. All right, so we are going to finish off with our composite solid. So we need to find the volume of the composite solid, and notice that this area right here, this part of the solid's volume, is not necessarily there. So we need to find everything else that is below it. So we need to define the volume. We need to take the volume of our cylinder, which is our big shape, minus the volume of our, and that is one of our new vocabulary words, our hemisphere. So they have given us our cylinder equation from the last section is pi r squared times our height. And our new one that we learned today, half of our sphere would be 1/2 4/3 pi r cubed. So really we're only plugging in our radius and our height. So our radius is 3 squared times our height of our whole cylinder would be 5. So that gives us 45 pi. And then moving over to our hemisphere that we want to subtract from it, we know that our radius is still 3. It's still the same as our cylinder, so that gives us 18 pi. After we subtract those, our final answer would be 84.82. So it's about 84.82 cubic inches without that hemisphere in the cylinder. Alrighty, I think we are finished through the notes, so you may go ahead and stop this video and work on those checkpoints on the next page. Working those carefully and understanding and really familiarizing yourself with the new equations for surface area and volume. So go ahead and write those two equations 3 times on the top of this checkpoint page. And then I will show you the answers. For the first checkpoint, gives us 1 meter squared. Again, we're in surface area. Number 2 is 6.5 inches. I'm finding my radius. Number 3, I'm finding my volume, so I need to make sure I am in cubic centimeters. And last, this is almost the reverse of our last example, but instead of subtracting, since they are both on the outside, I'm going to add those values, and that is my third example. So if you have any questions, let me know later, but we are completed with Chapter 12, Section 6.